Good evening, madam. This is Ranjit Kumar Reddy from CSC Department E section. Today, my topic is origin of energy bands. The concept of energy bands in solids arises from the quantum mechanical behavior of electrons in a material, particularly when atoms come together to form a solid. Here is a breakdown of energy band originate. Atoms, orbitals, and energy levels. N associated electrons occupy specific energy levels or orbitals. Example sp,d orbitals, each of which has well-defined energy. These energy levels are discrete because the electrons are bounded to individual atoms and are quantized due to the nature of quantum mechanics. Formation of a solid. When atoms come together to form a solid, the individual atomic orbitals of each atom interact. This interaction occurs because electrons are no longer confined to individual atoms but are now influenced by the entire lattice of atoms. In a solid, especially crystal solid, the atomic are arranged in a regular repeating pattern and the wave functions of electron overlaps. Splitting of energy levels. Due to interaction, the discrete energy levels of isolated atoms split into many closed spaced energy levels. This splitting occurs because electrons in the same energy level interact with electrons from neighbors. As the number of electrons, the splitting becomes more. Large solids the become slow closed shaped form a continuous band known as energy band. Condition bands and valency bands. The energy bands are divided into two main regions. Valency bands, the band of energy levels that electron occupy at lower energy, typically associated with the outermost electrons of the atoms. Conduction bands, the bands of energy levels above the valency band where electrons are free to move, allowing electrical conduction. The gap between the valency band and the conduction band is called the band gap. The gap is crucial for determining electronic properties of materials, insulated semiconductors and conductors. Formation of band gaps. In materials like insulators, the valency and conduction bands are separated by large band gap, meaning electrons cannot easily jump from the valency band to the conduction band. So these materials do not conduct electricity. In conductors, the conduction bands are is very close to the valency bands, allowing to move freely, which results in good conductivity. Conductors, the band gap is small enough that certain conditions applying external electrons can jump from the valence band to the conduction band, allowing for controlled conductivity. Quantum mechanics and electron wave functions. The functions of energy band is grounded in the quantum mechanics. Electrons, a solid wave functions, and wave functions are affected by the periodic potential of crystal lattice. Bohr's theorem. This theorem describes the wave function of electron in periodical potential. The wave function can be written as a plane wave modulated function that has the same periodicity as the lattice. This leads to association of band rather than the discrete energy levels as seen in the periodicity lattice means that the allowed energy state from the bands higher than the discrete levels, and these bands are separated by the region where energy state are allowed. Band structure and the Bernoulli zone. The concept of reproposal space of crucial in understanding energy bands. The Bernoulli zone is a fundamental region in reciprocal space that defines the energy state of the electrons in the solid sleep describe how electrons depends on momentum, and the structure is a plot of electron energy against momentum within the ball. Shape of the band structure determine the electronic properties of the materials. The origin of band lies in the behavior of electrons in a solid and the interaction between atomic orbitals. These interactions causes the discrete energy levels of isolated atoms split and form continuous band, which plays a crucial in determining the electrical and optical properties of materials. Thank you. అయిందప్ప కష్టమన్నా